Alrighty, so here is your test review for vectors and parametrics. Remember, the best way for you to handle this review is not to just sit down with a blank review and work it all with me, but to have your review done and then be able to fast forward through and just kind of check your answers and look at the questions you need to. If you want to watch the whole video, that is fantastic, but it will be to your benefit to have it actually done on your own first. Okay, so we are going to graph this set of parametric equations. We have a domain that they have given us from 0 to 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to take these numbers, I'm going to substitute them into this equation to get my x values. I'm going to have to estimate on a calculator with the square root just to the nearest tenth is good enough to get it graphed. So this would give me a 1, then a 2, then 2.4, 2.7, 3, 3.2, 3.4, 3.6, 3.8. Then I take the 0 through 8, substitute it into this equation to get my y values. So that would give me negative 4, negative 2.5, negative 1, 0.5, 2, 3.5, 5, 6.5, and 8. Okay, so then I want to plot this over here. So this is the ordered pair that I'm plotting. I'm going to go to 1, negative 4, 2, negative 2.5, 2.4, negative 1, 2.7, 0.5, 3, 2, 3.2, 3.5, 3.4, 5, 3.6, 6.5, and 3.8, 8. Something pretty much like that, which means it will look like this. Then I needed to put in my arrows. So I started here, and my direction of movement is like that. So there you go. Alrighty, number 2, same idea. My domain goes from negative 3 to 3, so negative 3, negative 2, negative 1, 0, 1, 2, 3. Take these values, substitute it into this equation to get my x values. That will be negative 9, negative 6, negative 3, 0, 3, 6, 9. Take these same values, substitute them into the y, and I get 4.5, 2, 0.5, 0, 0.5, 2, and 4.5. These are the ordered pairs that I'm going to plot. So I'm going to go to negative 9, then 4.5, negative 6, 2, negative 3.5, 0, 0, 3.5, 6, 2, 9, 4.5. And that is what this one looks like. Remember, there are no arrows on the end to indicate that it goes on forever. Just looks like that. Okay, so then this says, write each set of parametric equations in rectangular form and note any restrictions on the domain. So I got to look at that at the beginning. Now, I could have given you a restriction like we did on the other, saying that t is between 0 and 4 or something like that. This one didn't. So I look at this, and in order for this to give me real answers, I know that t has to be greater than or equal to 0, because I understand my square roots. Then I'm going to substitute so that I can actually find x and y. I'm going to start with this one. I'm going to square both sides, so I get that x squared equals 5t, so I can get rid of the square root. So since x squared equals 5t, I can substitute it into right there, and I'll get y equals negative x squared over 3. Then since t is greater than or equal to 0, I take the 0, substitute it into here, and I get 0 again. So x is greater than or equal to 0. So on number 4, when I start, I was not given a domain restriction, and there isn't anything. I have a quadratic and a line, so I don't need one right there. I am going to, see, I will take this one and solve for t. So this would give me y plus 1 equals t over 2. And so then that would give me 2y plus 2 equals t. So now I'm going to take that and substitute it in here. So this would give me x equals 2y plus 2 squared plus 3. Solve for y, so x minus 3 equals 2y plus 2 squared. Take the square root of both sides, so I get plus or minus the square root of x minus 3 equals 2y plus 2. So then I would subtract 2 from both sides and get plus or minus square root of x minus 3 minus 2 equals 2y. So then I can have plus or minus the square root of x minus 3 minus 2 all over 2 equals y. There's a couple other forms of this. I could have 1/2. So let me just do it. Or I could have plus or minus 1/2 times the square root of x minus 3 minus 1 equals y. Either one of those is fine. But I do have a domain restriction here either way because I have this square root. So because of this square root, x has to be greater than or equal to 3. And regardless of which one of those two you use, it's the same domain restriction. All right, so let's look at number 5. Trying to write these in rectangular form. So I need to solve for cosine here. So x over 2 equals cosine theta. Y over 7 equals sine theta. Then I know that cosine squared theta plus sine squared theta equals 1. So that means I get x over 2 squared plus y over 7 squared equals 1. So x squared over 4 plus y squared over 49 equals 1. And when I have an x squared and a y squared, I don't try and solve for y. Okay, so then on number 6, to solve for cosine, I would have to add 3 to both sides. So I'm going to get x plus 3 equals cosine theta, and y over 4 equals sine theta. We do the same thing. Cosine squared theta plus sine squared theta equals 1. I'm going to leave this first term alone, but I'm going to clean that one up. So get y squared over 16 equals 1, and you are done. Okie dokie. 7 and 8. Soccer goalie makes a save, then drop kicks the ball down the field. The ball travels at an angle of elevation of 40 degrees. So theta equals 40 degrees. Initial velocity of 30 feet per second. So v sub 0, 30 feet per second. from a height of 1.5 feet, so h sub 0, 1.5, and your gravitational constant is going to be 32 feet per second. Okay, maximum height of the ball. How do we find the maximum height of the ball? Remember your maximum, we can find the maximum time. Maximum equals negative b over 2a. So in order for me to figure that out, I need my y equation. So y equals t times my initial velocity, which is 30, times the sine of the angle, which is 40, minus half the gravitational constant, 16 t squared, plus the initial height, which is 1.5. Okay, so if I went negative b over 2a, that's the time at which it's maximum. The b is the 30 sine 40, so that's negative 30 times the sine of 40 over 2 times negative 16. I'm going to put that into my calculator, and I get that t is 0.603 something something something. I use that exact number, not the rounded number, to then, since I actually want the maximum height, I substitute that back into here, and I would get that y equals 7.310 feet, and that is the maximum height. And just as a reminder, this negative b over 2a stuff, that is an Algebra 2 concept. The pre-cal part of this is the equation that we're using. Okay, so then it says, what was the horizontal distance of the projectile at its maximum height? Well, I know the time at which it's the maximum height, so I use that exact number from the calculator again, so that I can put that into my x equation, which is going to be t times the initial velocity, which is 30, times the cosine of theta, which is 40. Substitute that in, again, not typing in my decimals, and I get that x is equal to 13.849 feet, and that is the horizontal distance. All right. So for questions 9 and 10, we have a projectile that is fired from the ground. That means that the initial height is 0. Projectile travels with an initial velocity of 55 meters per second. Angle of elevation is 60. My gravitational constant, since that is meters, is going to be 9.8. All right, so it says find the difference in the height of the projectile after 2 and 4 seconds. So I have to find t equals 2 and t equals 4. So that means that my first y value would be t, which is 2, times the initial velocity, which is 55, times the sine of the angle, which is 60, minus 4.9 times 2 squared. And my second one would be 4 times 55 times the sine of 60 minus 4.9 times 4 squared. So the difference would be y2 minus y1. So I can just type all this in, subtract all of this right here, and I get that the height difference equals 36.463 meters. All right, so then I want to find the total horizontal distance the projectile traveled at the time it reached the ground. So I need to know when it reached the ground. So I've got to start with my original equation again. T times 55 times the sine of 60 minus 4.9 times t squared. Set that equal to 0. T times 55 times the sine of 60 minus 4.9t equals 0. Set each one of those equal to 0, so t equals 0. That's the first one, not the one I want. And then I set 55 times the sine of 60 minus 4.9t. Set that equal to 0. So I'll get 55 times the sine of 60 equals 4.9t. So t equals 55 times the sine of 60 divided by 4.9. Okay, so I put that in my calculator, and that gives me t equals 9.721 seconds. So this is my other time. This one is not the one that works for me. Even though this is what I get, not my final answer, and I'm not typing that decimal back in, that is the time it takes to go the entire horizontal distance. My horizontal equation is x equals t times the 55 times the cosine of 60. So then once I substitute this in from its exact form, I will get 267.319 meters, and that is the total horizontal distance. All right. Let's look at vectors. Magnitude and direction angle. So the magnitude of vector P is going to be the square root of 3 squared plus 9 squared. So that's the square root of 90, which is 3 times the square root of 10. Your square roots are going to have to be simplified. Oh, I'm sorry, I can put the answer down here. Magnitude of P equals 3 squared root of 10. Direction angle, theta is the tangent inverse of B over A, so that's 9 over 3, which is 3. So theta equals 71.565 degrees.